Hi, welcome to video 1.1 for Algebra, our first video, and we're going to be reviewing some things from foundations that you learned. So a coordinate graph is the intersection of two number lines. So we have our horizontal number line, and that's the x-axis, and we have our vertical number line, and that's the y-axis. And the origin right here, 0, 0, is the point where the axes intersect. There are 4 quadrants in a coordinate plane. So this is the first quadrant, and I always remember that because it's the first one you learn when you're little, because it's got the positives and the positives. And this is quadrant 2, quadrant 3, and quadrant 4. And we always use Roman numerals to label our quadrants. It's just a convention in math. A point on the graph is represented using ordered pairs, and an ordered pair is written of the coordinates in the form x, y. X comes before y just like it does in the alphabet. The x value is called the x coordinate, and it represents the horizontal placement of the point, and then the y value is of course called the y coordinate, and that represents the vertical placement, how far up or down it is. Okay, so here I will do the first one, and then I want you to try the rest of them. So the first one, 2, 3. This is the x-coordinate, so on the x-axis we go over 2 and then up 3 like that. So that's point A. Please try the other 4 points and then come back and I'll give you the answers. Here's your answers. That's what it should look like. And then moving on, an ordered pair is a solution to an equation. Meaning if you have an x and a y in an equation, the ordered pair that is on that line would satisfy that equation. We'll talk more about that later. A set of ordered pairs is called a relation. And a relation can be represented in a few different ways, and we'll take a look at some of those now. So a function can be thought of a machine that assigns one output to every input. So function is really important. That is a special type of relation, and that's what this chapter is going to be about, is functions. And we talked about functions last year, which you may or may not remember, but we'll get more into them this year. So this right here is the name of the function. This is function f, and we say f of x equals 3x plus 4. So this is the actual function. This is saying what number to plug in, and f of x means the output of the function f when our input is x. Another way, so you probably mostly remember this as y equals 3x plus 4, and they're the same thing. It's just a different way to say it. This is in function notation, and this is not. Okay, so function notation. Why do we have function notation? Because it gives us a little bit more information sometimes. It tells us what we're putting into the function and allows us to figure out what comes out. So, for example, we're going to look at f of 2 here using the function machine model. So input is 2, and that's why we use that little parentheses. And our function is 3x plus 4, but instead of x, we know that our x in this particular case is going to be 2. So we would put 3 times 2 plus 4, and then 3 times 2 is 6 plus 4 is 10. So our output would be 10, and that means that f of 2 is 10, and our ordered pair is 2. That's our x value. Input and x are the same thing, and output and y are the same thing. So 210 is going to be our ordered pair for that one. Let's try another one. So in this one, our input is going to be -1, and we have 3 times -1 plus 4, all I'm doing is I'm taking this function up here, and when I get to the x, instead of the x, I know that x is -1, so I'm putting -1 in there and then solving it. So 3 times -1 is -3 plus 4 is +1. So f of -1 equals 1, and that means my ordered pair, this is my x value, and this is my y value, and so -1, 1 is my ordered pair. Okay, moving down here, you're going to practice. This time we have 2 different functions. So we have function f, which is x squared plus 3, and we have function g, which is x plus 1. So you don't have to draw the little machine every time. That's just sort of an idea you can think about in your head if it helps you. Just do the work over here, and we'll come back in a minute and check answers. Okay, here are the answers on the bottom. So the ones that are boxed in, those are my answers, and I've got my work there if you got a different answer and are looking for how it's done. Okay, moving on. Some other things we need to know about relations. They can be either discrete or continuous. So the main difference, if you're looking at these, is that discrete data is separate and continuous data is connected. So continuous data can be expressed as like an equation, and discrete data would be expressed as different points in a graph. And we'll talk more about that a little bit later in the chapter. Okay, so here are some things that all kind of mean the same thing. This is the same relation, but we can use different words to describe them. So for example, input can also be called x. That's the same there, but it's function notation. It can be called the domain, and it can also be called the independent variable. Output can also be called y. It can be called f of x. It can be called range, and it can be called dependent variable. And the reason it has so many different names is because we're sort of talking about different aspects of it when we use these different names. So right now, just kind of take it in, make them look familiar. You do not have to memorize them. Just be familiar with them, and we will talk more about them and what the different words for them mean as we go along. So how can we describe what domain is? Domain is all possible x values, and the range is all possible y values. And then it changes the way that we describe it on whether our data is discrete or continuous. So for example, our domain here would be all of our x values. So this point right here has an x value of 1. So we would say 1 and 2, and then it's also 3, 4, 5, and 6. So it's 1, 2, 3, 4, 5, and 6. And I couldn't say it's 1 through 6 because then that would include like 1.5 and things like that, and that's not part of our domain. Our range, the lowest range we have is -1, and then 0, 1, 2, 3, and 6. So we would put -1, 0, 1, 2, 3, and 6. Okay, and then for our domain here, I'm looking, so these arrows mean that it goes on forever. So that means that eventually, if this kept going, my domain, it would hit every possible thing on that x. Every possible x would eventually hit this function. So our domain is all real numbers, and that R with a double line here means all real numbers. And then same thing for range. If this, since this is going up and this is going down, eventually this line would hit every single y value there was. So our range would be all real numbers as well. Okay, if that makes sense, fabulous. If it doesn't, we are going to work a little bit more on it later, so no worries about that. And please write down any questions that you have, and we will talk about them in class.